Hello everyone. So so far we have learned that so if you have two states, it's E1 and E2 are the two states. Okay. So this is state one, state psi one. This is a state psi two. Okay. So we assume that we have taken that the particle is in the state psi 1 means energy level E1. Then the coefficient of without perturbation, the coefficient will be Ea of 0. This is like psi A, this is psi B, this is Ea and Eb. Okay, so the particle is in the state psi A, so that we assume that the coefficient will be 1 at t is equal to 0. So there is no time progress. So after that time, at, so there is no particle in a state psi b, means energy level b, Eb. So we have taken that coefficient of 0, Cb, coefficient Cb 0 is equal to 0. When time progress, like after time t1, after time t, okay. So after time t, we have assumed that Ca of t which is equal to 0, Cb of t is equal to 1. Okay. So yesterday we have find out the coefficients of Ca and Cb. So today we are going to discuss about the zeroth order and first order and second order, as same as the it is some analogous to the time independent perturbation theory. Okay. So if the zeroth order, so same as there is no perturbation to the system, so this is the same as above. Okay. To calculate the first order approximation, we we insert these values on the right side of the equation 9.13. So what is the 9.13? Let me see. Okay. uh, so this is the 9.13th equation. This is the 9.13th equation. So this is the 9.13. Please note down these equations, Ca dot and Ba dot. Okay. Please write down in your notes right now. So the first order, so in from the 9.13th equation, there is a Ca, okay, Ca dot, which is equal to Ca dot, which is equal to minus I by H cross. There is a perturbation of AB or something. I didn't remember. There is exponential term and there is exponential term into dt. Okay. So there is a coefficient of Cb also in that Ca dot లో మనకి Cb యొక్క కోఎఫిషియంట్ కూడా ఉంది. So if you keep it like that, then we can write it as dt, sorry, Ca dCa by dt, which is equal to 0, because the coefficient, the zeroth order of Cb of t is equal to 0, right? So it is equal to 0. Then Ca is equal to some constant. The constant is has taken as 1. This is the first order correction. This is the first order correction of coefficient which is equal to 1. So next, take the value of Cb dot, and now the zeroth correction of Ca of t is equal to 1. So keep it in the 9.13th equation. You will get like this. Then integrate on both sides. Do the integration on both sides with respect to time, with respect to t, with respect to now. So you will end up with this integral. Okay. Now we insert these expressions on the right to obtain the second order approximation. So now we insert these expressions on the right. Uh, on the right we will to obtain the second order approximation. So dCA by dt, which is equal to, so in the 9.13th equation, the equation 9.13 equation, so there is a Cb term. Insert that Cb term here, then you get a second order time independent perturbation. Okay. So if you do the integration on both sides, you will get this expression. Like say, just do integration. Okay. So let's see the sinusoidal perturbation. So what do you know about the sinusoidal wave? Sinusoidal waves are like cos waves or sine waves. That what we call it as sinusoidal. Okay. These are all sinusoidal. So these are sinusoidal. Cos waves or sine waves are the sinusoidal waves. Okay. So here perturbation is in the sinusoidal form. So that h prime of r comma t, which is equal to v of r. So perturbation will happen in only the potential only. Perturbation is only happen in the potential. So perturbation which is equal to means Hamiltonian perturb in the Hamiltonian, which is equal to v of r cos omega t. Okay. So that you will get, if the suffix is ab, then the potential suffix will be ab. So we can write vab in the form of inner product of psi a v psi b. Okay. Complete inner product of psi a psi b v psi b. As before, I will assume that diagonal matrix. I already discussed that the diagonal matrix of elements will be 0. So I assume that the diagonal matrix elements vanish, since this almost always case in the practice. So if we want to know the first order first order correction in the coefficients, so we find out that uh, we found that minus I by h cross, which is equal to 0 to t h prime ab exponential I omega t t prime dt. Okay, this is what we obtained. Okay, see here writing is not good, but follow my words. Okay, listen carefully. So then insert VAB, means not VAB. So insert in the term, in the place of h prime AB, insert this thing, the VAB cos omega t. Then VAB is some constant term which will come, which is a function of only the r. So we are integrating with respect to time t. So this integral, this inner product will come out from the time integral. Okay, so which is equal to minus VAB by 2h cross. So divided by, so we can write the cos in terms of exponential by like this. So means cos omega t, which can be written as e power omega t plus e power of minus omega t I omega t, sorry, cos omega t, which can be written in the exponential form, e power of I omega t plus e power of minus I omega t divided by 2. Okay, so now we multiplying this cos omega t in the exponential form by uh, this e power of omega t prime. Okay, then you will get this expression. So after apply the integration, after the integration so after the integration, if we substitute the values, then you will get, this is CB of t. Okay, this is the answer. The thing simplifies if we restrict ourselves, the driving force means omega is the driving force and transition frequency is omega naught. So if the omega is nearly close to the omega naught, the second term in the bracket dominates. The second term in the bracket will dominate. So specifically means the here minus 1 by some 0, which is equal to 0, means which is equal to this whole term becomes uh, the second term becomes infinity. So that so second term is going to be dominating compared to the first one. This is, so sum of driving force and transition frequency, which is much greater than the less than the difference of the two frequencies. This is not much of limitation, since perturbation at other frequencies have the negligible probability of causing the transition anyway. Dropping the first term, we have So comparatively this term is dominating. So if we neglect this first term, we will not cause anything to the to the equation, to the coefficient, to that our problem. If we drop out the first term, so it will not cause anything so to the solution, because this term is going to be infinity, is very large. So it's like the taking the water from the ocean. It's not uh, it will not affect anything to the ocean, right? To the whole water of the ocean. It's same as like that. It's a some kind of example only. So drop out the first equation. So take it out the e power exponential of I omega naught uh, omega naught minus omega t by 2 from this second term. This is, we are neglecting this term completely. Okay, we have only this term. So take it out e power of I omega naught minus omega t by 2 from this expression, from this term. Then you will get, so if we multiply this so like 1 by 2 into 1 by 2, which is gives rise to 1, right? It's same like that. So bases are same, add the coefficients. Here bases are same, add the powers. Then you will get 1 here, as same as above. Okay. So if we divide by 2i on numerator and denominator, then you will get sine function. So if we square it, means if we find out the probability that particle which stated out in the states IA will be found at the time t in the states IB. ఇప్పుడు మనం ట్రాన్సిషన్ ప్రాబిలిటీ ఫైండ్ అవుట్ చేస్తున్నాం. సో ట్రాన్సిషన్ ప్రాబిలిటీ విచ్ ఈజ్ ఈక్వల్ టు సై స్క్వేర్. ఓకే, ఇనీషియల్గా మనం ఒక పార్టికల్ అన్నది ఇక్కడ స్టేట్ సై ఏలో ఉందనుకున్నాం, సై బిలో లేదు. సో ఈ యొక్క ట్రాన్సిషన్ జరిగినప్పుడు ఫ్రమ్ సై ఏ టు సై బి టు psi A or psi A to psi B. So we don't know where the particle is in the which state. So in order to find out that particle is in where the particle is, so what we have to do? We have to do the probability density. So the probability density tells about that where the particle will be. So okay. So then see, this is the complex one. So first do the complex conjugate of CB of t. Okay, then you will get plus here. Okay, then multiply C conjugate of CB of t into CB of t. Okay, if you multiply these the two coefficients, then you will get the transition probability. Okay, this is the today's last class about this is not a today's last class. So see, if we keep the sine square, one second. So if we keep the sine square sine square omega minus omega t by 2, which is equal to sine n pi. If we keep sine square n pi, so not sine square n pi, so we can write it as 2 cos theta 1 minus 2 by 2, which can be written as 1 minus cos 2 omega naught minus omega t by 2. So we have t here, divided by, so ante kada 2 sine square so 1 minus cos 2 theta by 2. ఒకసారి 1 సెకండ్ నేను ఇప్పుడు cos 2 theta అంటే ఏంటి? cos 2 theta is equal to cos square theta minus sin square theta. Okay, so which is equal to cos square theta is equal to 1 minus 2 sin square theta. So if we do like this, then okay, so now sin square omega naught minus omega t by 2, which can be written as 1 minus cos omega minus omega naught t whole by 2. Okay, when we so if t is equal to, when the ఇప్పుడు t is equal to 0 పెడితే ఏమవుతుంది? 1 by 2 అవుతుంది. సో pi by 2 పెడితే t is equal to pi by 2, then cos pi by 2 will be 0. సో ఇప్పుడు 1 సో 2 pi n pi n ఇంటిజర్స్ పెడితే కనుక, సో నాట్ n pi, but suppose sin square n pi పెడితే, so sin square will cancel out, so omega naught will be, when it will be 0, సో మనకి ఇక్కడ ఈ ప్రాబిలిటీ ఉంది కదా, ప్రాబిలిటీ with respect to time, transition probability in the terms of time from A to B. So if you see this, the transition means the main term is sine wave, so which is in the graph, we'll get a graph, sine graph. So you have a square here. Actually you will have one wave will be in the upside and one wave in the downside of the x-axis. Okay, so but if we square it, this upside the downside will go into the upside. Okay, అందుకే మీకు ఇప్పుడు ఇక్కడ సైన్ స్క్వేర్ ఉంది కాబట్టి మీకు ఈ స్క్వేర్ ఇలా వచ్చింది. ఓకే, సో ఇప్పుడు సైన్ స్క్వేర్ ఒమేగా నాట్ మైనస్ ఒమేగా టీ బై 2ని మీరు విచ్ ఈజ్ ఈక్వల్ సైన్ స్క్వేర్ ఎన్ పైగా రాసుకున్నారు అనుకో, సైన్ స్క్వేర్ క్యాన్సిల్ అవుట్ అవుతుంది. సో విచ్ ఈస్ టీ ఈజ్ ఈక్వల్ టు 2n pi by omega naught minus omega. ఓకే. ఇప్పుడు n ఈజ్ ఈక్వల్ టు 1 పెడితే సో టైమ్ యాక్సిస్లో మీకు ఫర్ ఎవ్రీ ఇంటర్వల్ విత్ ఆఫ్ ద ఇంటర్వల్ విల్ బి 2 π. ఇప్పుడు n ఈజ్ ఈక్వల్ 1 పెడితే మీకు 2 π డివైడ్ బై ఒమేగా మాడ్ ఒమేగా నాట్ మైనస్ ఒమేగా వచ్చింది. n ఈజ్ ఈక్వల్ 2 దగ్గర 4π ఒమేగా నాట్ మైనస్ ఒమేగా వచ్చింది. సో n ఈజ్ ఈక్వల్ 3 దగ్గర 6π డివైడ్ బై ఒమేగా నాట్ మైనస్ ఒమేగా వచ్చింది. సో మ్యాక్సిమం ప్రాబబిలిటీ ఎంత అవుతుంది వెన్ సైన్ స్క్వేర్. సో t/2 అన్నది ఇప్పుడు ఇది సైన్ స్క్వేర్ ఒమేగా నాట్ అంటే వీ కెన్ రైట్ ఇట్ యాజ్ -1 కాస్ ఒమేగా ఒమేగా నాట్ మైనస్ ఒమేగా ఇంటూ t డివైడ్ బై 2. సో at t is equal to 0, minus 1 minus cos at t is equal to 0 cos omega is equal to 1, cos 0 is equal to 1 కదా. సో ఎవ్రీ π/2 దగ్గర you will get 1. సో you will in the denominatorలో మీకు 2 వస్తుంది. సో మీకు mod so at every multiple of π/2 you will get 2 here. So okay. So at π/2 this value goes to 1. Okay. Not only π/2, it's pi. At not t is equal to pi. This is the maximum amplitude. This is the maximum amplitude for the wave. Okay. So if we do the Fourier transformation for this of this Fourier p of t, will get the frequency domain. It's a time domain, right? If we do the Fourier transformation, we'll get the frequency domain. So the graph will be like this. Okay. So what we have learned today is we have learned the zeroth order, first order and second order. So from that we have find out the transition probability. Okay. Okay, thank you.